You know, have you ever stood by a powerful, rushing river, and then, maybe later that same day, sat by a perfectly still lake? They might just seem like different moods of the same thing, right? Just fresh water. But what if I told you that the simple difference between moving and standing still creates two completely, fundamentally different ecological worlds?
I mean, look at this. On one side, you've got the raw kinetic energy of flowing water, constantly carving and shaping the landscape. And on the other, you have the profound stillness of a lake, a calm surface that hides this incredibly complex, layered world right beneath it. These aren't just different scenes, you guys. They are the very heart of two distinct types of ecosystems.
All right, so here's how we're going to break it down. First, we're going to explore the world of moving waters. Then we'll dive into the stillness of standing waters. After that, we'll see how life has to adapt to each one, and finally we'll tie it all together and see how these two worlds are actually connected. Okay, first up, let's talk about the ecosystems that never stop moving. These are basically the arteries of our continents, right? The rivers and the streams. And in scientific terms, we call them lotic systems.
And the name itself gives us a huge clue. Lotic actually comes from the Latin word for washed. And that's exactly what these systems are. They are constantly being washed by flowing water. This one simple fact defines literally everything about them.
So what really makes a lotic system tick? Well, for starters, the flow is always unidirectional. It's a one-way street, always moving downhill. This creates a really high-energy environment where the riverbed itself is constantly changing shape. But what's super interesting is how nutrients move. See, unlike in a lake where they kind of cycle in one place, here they spiral. A nutrient gets used by an organism, then it gets released, and then it's washed further downstream before it's used again. This creates this incredible spiral pattern all the way down the river. It means life downstream is directly dependent on what happens upstream.
You can just feel that power, can't you? It's a force that carves canyons, tumbles giant boulders, and it means that for anything to live here, life is just a constant struggle to hold on and not get washed away.
Okay, now let's hit the brakes. Let's shift gears to that other world, the world of standing water. Here, in the realm of lakes and ponds and swamps, we find what we call the lentic ecosystems. And again, the name tells the story. Lentic comes from the Latin word for sluggish. So this is not a high-energy one-way street. It's much more like a deep, slow-motion cauldron, where completely different processes can unfold over really long periods of time. You know, because the water doesn't really flow, it can separate into layers based on temperature, kind of like oil and vinegar. You get a warm, sunlit layer on top, and then a cold, dark, often oxygen-poor layer way down at the bottom. This creates totally different neighborhoods for life, all within the same lake. And what's really wild is that even still water moves. Strong winds can actually cause the entire body of water to slosh back and forth in these huge, slow, invisible waves called seiches.
So, next time you look out at a calm lake like this one, just remember you're only seeing the surface. Beneath it is this highly structured, layered world with dynamics that are completely alien to a flowing river.
Okay, so we've got these two very, very different physical environments. The obvious next question is, how does that affect the life that calls these places home?
This is the crucial point. Where does the food chain get its energy? In a lotic system, the energy largely comes from outside. It's what we call allochthonous. Think of leaves, bugs, and all sorts of organic matter falling into the stream from the land around it. But in a lentic system, the energy is primarily generated from within. It's autochthonous, created by phytoplankton and algae soaking up the sun right there in the water.
Let's think of it this way. A narrow, tree-covered stream gets most of its food delivered from the outside, like a constant stream of takeout. But a wide-open lake? That's more like a solar-powered farm, growing its own food, the algae and plants, right there in the water. It's the difference between an ecosystem that orders in and one that grows its own groceries.
And this, of course, leads to totally different forms of life. In lotic systems, life is all about holding on for dear life. Insects have these flattened, streamlined bodies. Algae grows attached to rocks. It's all about resisting the flow. But in lentic systems, life is about floating and navigating the water column. You've got microscopic plankton just drifting, plants with big floating leaves, and fish that can actually migrate up and down through those different temperature layers.
So we've set up these two really distinct worlds, right? The lotic and the lentic. But you know, nature is rarely that simple. The line between them, it's a lot blurrier than you might think.
In fact, they're not separate at all. They are deeply physically connected.
The reality is that lotic and lentic aren't really separate boxes. They're part of a continuum. A fast, narrow, shaded stream way up in the mountains slowly becomes a wider, slower, sunnier river as it moves downstream. And eventually, that river flows into a lake, delivering everything it's been carrying. The moving world directly feeds and then becomes the still one. They aren't two different things. They are two phases of the exact same journey for water.
Which brings us to a really critical modern thought. When we build a dam, what we are doing is running a massive ecological experiment. We are forcibly halting a moving Lotic river and turning it into a still lentic reservoir. We flip its energy source from takeout to homegrown, we completely change its physical structure, and we rewrite the rules for every single living thing inside. We block fish migrations, we alter water temperatures, we trap sediment. So the question we're left with is this: what are the long-term consequences of this global re-engineering of our planet's freshwater arteries?